Welcome to the DIY Honda Garage channel. The DTC P2175 indicates a fault within the throttle actuator control system, specifically related to low airflow detection. When the throttle body's blockage rate reaches 100% of a predefined threshold, the Powertrain Control Module, PCM, recognizes this anomaly and stores the trouble code. The throttle body is crucial for retake into the engine, influencing performance, fuel efficiency, and emissions. Located between the air cleaner and the intake manifold, it works with various sensors to maintain optimal engine operation. This condition could lead to several performance issues, making early diagnosis critical. The error P2175 specifically relates to the throttle actuator control system's inability to maintain the correct amount of airflow required for optimal combustion. This system is designed to adjust the throttle valve based on input from the Powertrain Control Module, PCM, and various sensors. The throttle body is typically found situated between the air intake duct and the engine's intake manifold. It plays a vital role in regulating the air entering the engine, thereby ensuring that the correct air-to-fuel ratio is achieved. When airflow is hindered, performance issues such as rough idling, poor acceleration, or increased emissions may occur. Several factors could lead to the P2175 error code being stored. A blocked throttle body can prevent an adequate flow of air, causing the PCM to recognize an issue. Additionally, faulty sensors like the mass airflow (MAF) sensor or inlet air temperature (IAT) sensor can misinform the PCM about the actual airflow, leading to erroneous readings. Finally, leaks in the intake system can also disrupt airflow, thereby changing the conditions under which the throttle actuator operates. Thorough inspection of each of these components must be conducted to identify the specific cause. Drivers may experience a range of symptoms when the DTC P2175 is triggered. Commonly, the vehicle might exhibit poor engine performance, including sluggish acceleration and decreased responsiveness. This occurs due to inadequate airflow, which can lead to inefficient combustion. Additionally, the vehicle may use more fuel than normal, driving up operating costs for the owner. Moreover, fluctuating engine speeds or unusual idling can be signs of a malfunctioning throttle system. Recognizing these symptoms early can lead to a quicker, more effective diagnosis and repair. The first troubleshooting step involves setting the vehicle to on mode and allowing the engine to cool until the engine coolant temperature (ECT) sensor reads 77 degrees Fahrenheit, 25 degrees Celsius or less. This step is crucial as it ensures accurate readings during the diagnostic process. After cooling, start the engine and let it idle for at least 10 seconds. During this period, monitor the Honda Diagnostic System (HDS) for the P2175 DTC. This step establishes a baseline for identifying any fault codes that may occur at engine startup under normal conditions. The second troubleshooting step is to conduct a thorough visual inspection of the intake air system components, including the air cleaner element and housing. Ensure there are no blockages or excessive dirt, as these can impede airflow to the engine. Specifically, check the condition of the intake air duct for any damages or obstructions that may affect air intake. This step is necessary to rule out simple, visible issues before proceeding to more complex inspections. Any abnormalities here could directly influence the performance of the throttle actuator. The third step involves inspecting the inlet air temperature (IAT) sensor. First, note the ambient temperature, then turn the vehicle to on mode while quickly recording the HDS IAT sensor value. This allows for a comparison with the recorded ambient temperature. There should be a small difference of less than 5.4 degrees Fahrenheit, 3 degrees Celsius. Any significant deviation suggests a malfunctioning IAT sensor. If abnormal readings are noted, this indicates that the sensor may not be accurately relaying information on air temperature, impairing air intake regulation. In the fourth step, start the engine and allow it to idle. You need to meet specific conditions. The engine coolant temperature ECT sensor must read above 158 Fahrenheit, 70 degrees Celsius. The continuously variable transmission, CVT, should be in P or N, and all electrical and engine loads must be turned off. Once these conditions are satisfied, maintain an engine speed of 2,500 RPM for 30 seconds while monitoring the MAF sensor values on the HDS. A normal reading is between 4.1 grams per second and 5.7 grams per second. If the value deviates from this range, it may indicate issues with the MAF sensor or related components. For the fifth troubleshooting step, turn the vehicle to on mode and compare the readings of the high-resolution manifold absolute pressure MAP sensor with the turbocharger boost pressure sensor value. There should be a slight acceptable difference, specifically less than 26.7 kilopascal, 7.9 inches, 200 millimeters in Huygens. If this difference is exceeded, it may indicate issues with the MAP sensor that could compromise the throttle actuator's performance by providing incorrect information on airflow conditions. Careful monitoring of these values is essential for identifying sensor malfunctions. The sixth step involves turning the vehicle to on mode to note the initial reading of the high-resolution MAP sensor. Subsequently, start the engine and let it idle. Then compare the current MAP sensor value with the previously noted value. Normal functioning requires that the MAP sensor value should change by at least 0.67 kilopascals, 0.2 inches H, 5 millimeters mercury from the recorded initial value. If it does not, the MAP sensor may be faulty, leading to improper air-fuel mixture and contributing to the low airflow issue indicated by the DTC P2175. In the seventh troubleshooting step, the engine should be turned on again to compare the turbocharger boost pressure with the barometric pressure readings from the HDS. There should be an acceptable difference of less than 26.7 cubic meters, 7.9 inches, 200 millimeters mercury. If the differences exceed normal values, it indicates a potential fault with the turbocharger boost sensor, which may directly impact the throttle actuator. By measuring these values, technicians can determine whether the turbocharger system is functioning correctly under various engine conditions, which is vital for performance. This step requires the technician to turn the vehicle on and take note of the turbocharger boost pressure reading. After recording this value, the technician should start the engine and hold it at 3,000 RPM without any load until the radiator fan activates, after which standard idle should resume. Next, adjust the engine speed to 4,500 RPM without load. The monitored TC boost pressure should change by at least 0.67 kilopascal, 0.2 inches per second. 5 millimeters inches per second compared to the initial recorded value. Failing to see this change indicates a potential issue with the turbocharger boost sensor that could affect overall engine performance and airflow quality. The ninth step involves conducting the Engine Throttle Control System ETCS test through the HDS. This test specifically evaluates the throttle actuator's response and function. Normal conditions require that the throttle actuator control valve operates as expected, indicating that it is indeed functioning properly. If the test reveals abnormalities, it suggests a malfunctioning throttle body that may require further inspection or replacement. This step is essential to ascertain whether the actuator is obstructing proper airflow and maintaining appropriate throttle response. In the final troubleshooting step, the technician should disconnect the throttle body inlet hose for access. Once disconnected, perform a cleaning of the throttle body, ensuring to eliminate carbon buildup, dirt, or any signs of damage in the throttle valve and bore. Normal conditions necessitate that there is free movement with no obstructions present. If any grime, carbon deposits, or physical damages are found, these issues can inhibit the throttle's ability to operate correctly, hence contributing to the low airflow issue indicated by the DTC P2175. Thorough cleaning is essential to restoring proper function. After completing all relevant repairs and inspections, it becomes critical to verify that all systems are functioning correctly. Start by reassembling the components that were previously inspected or replaced. Following this, conduct a test drive under various driving conditions to gauge whether the vehicle responds effectively without any performance issues. After the test drive, utilize the HDS to check for the presence of any error codes. If DTC P2175 does not reappear and the vehicle operates smoothly, it indicates a successful resolution of the issue. To prevent recurrence of the P2175 DTC, it's crucial to engage in regular preventive maintenance of the intake air system. This includes inspecting and replacing the air filter as necessary to ensure an unobstructed airflow into the engine. Additionally, routine cleaning of the throttle body can help maintain its functionality and prevent carbon buildup that could lead to blockages. It's also advisable to check the functionality of all related sensors periodically, ensuring they provide accurate data to the PCM for effective throttle control. By adhering to these practices, vehicle performance will remain optimal. In summary, the DTC P2175 signifies an important issue related to the throttle actuator control system and airflow. Understanding the role of the throttle actuator and maintaining optimal performance through proper airflow is critical for efficient engine operation. By recognizing the symptoms associated with this code, technicians can expedite the troubleshooting process. Conducting thorough inspections of intake components, sensors, and the throttle body itself is essential in identifying the root cause of the problem. Adhering to these protocols will not only resolve the DTC, but also enhance the longevity and efficiency of the Honda Civic's engine. Please like and subscribe to the channel. See you next time.